Still troubled by the low efficiency of bench testing? This video shows you how to easily solve test problems with just one click. Today we are going to record a video. Explain the CICD assembly line in the automotive industry. Before explaining the CICD assembly line in the automotive industry, let's take a look first. CICD assembly line in the internet industry. We know, nowadays, more and more companies. The good way to do it. Code warehouse management, and we use pipelines to do CICD. Let's look at one of the assembly lines. This assembly line, please to submit code to the feature branch. After submitting the code, the compilation will be triggered. Unit test, static code scanning, product packaging, push to product library, and deployment to testing environments. Then this can be understood as a pure software aspects of a CICD, but this CICD process actually extends a little bit. In fact, it can be extended to hardware. Suppose we are on a feature branch. After submitting a code, we don't just want to zip your software testing. Suppose we wish. We know, EVA software, testing more realistic environments. Then its test results are the most accurate. What if it's tested directly on a real car? The test passed, then this code is very likely to be okay. However, if you only test in a pure software environment, the test passed. It doesn't necessarily mean all the following processes are okay. Still in the process. What if we could add some hardware to it? If you go for the test, then our accuracy will improve. So when we, after deploying to the testing environment for testing, the testing environment, in fact, we can also understand it as hill bench testing. Then let's say we put one. The bench is tied to this assembly line environment. Let me know that within a team, every day, many people submit code to the branch. Then a situation will occur at this time. Valleys. A lot of people are submitting code to this branch. It will cause the previous test to not be completed, but the new code was submitted again, so it will lead to the students who submit later. I've been queuing up. That's a situation. Will reduce efficiency. What about another situation? When we submit the code to run to, when deploying to the hill testing environment, sometimes our hill bench, for a variety of reasons, something went wrong. At this time, suppose we are before get off work to do such a test. Then we had expected that when we came the next day, you can see a result. At this time, due to the failure of the bench, no one solved it. Then you can't see this result. This is also a manifestation of reduced efficiency. So what can we do to improve this efficiency? Then we can consider putting this assembly line bound to a hill bench cluster. What are the benefits after binding? That is to say, after this code is submitted, it's not about finding a fixed hill bench to do the test. Instead, choose one in a cluster of benches. The architecture is a little bit like this. Here we see it. This is what I wrote on the car electronics software. An article written by. This article now has 165 retweets. If you are interested, you can also check out this article. That means when my code is submitted, I triggered the automated test. Then this automated test, it wasn't on any particular bench. To do the test, it's in its pooling. Go and choose a suitable bench for testing. Since there may be some in our bench cluster, dozens of benches, or hundreds of benches, then the probability that all the benches are broken is very low. Then there is a very high probability at this time. We will definitely find a suitable bench, a working bench to do this test. That makes us come the next day. You can see the report immediately. That solves it, of course, due to issues submitted by multiple people at the same time. So many people submit at the same time. You don't need to wait for the previous person to finish the test. I can do the test. So this increases efficiency as well. So this is the flow. Let's take a look at the approximate process. Engineers submit code. After submitting the code, CICD is automatically triggered. During the triggering process, you can see it. It implements the processes we mentioned earlier. Then when it comes to the last step, we are going to deploy to a certain test bench. Do a test. Then it will notify the MappingSpace ALM system. Tell it, here's a test. The MappingSpace ALM system will go through its central dispatch system. Go to the bench cluster pool. Select a suitable bench for testing. So what about the bench cluster pool? Since there are so many benches, so choose a bench that works. It's very convenient. Then after the test is done, it will send this result through the central dispatching system back to MappingSpace ALM and establish traceability with requirements. In that case, it forms a link for efficient hill testing, and it forms a closed loop with demand. So let's take a look. How is it implemented in MappingSpace? So I went into MappingSpace, enter one of the projects. Under this project, we can see there's a test bench underneath the launch. That's on the test stand. Here, we can see we currently have multiple racks under management. You can also see one of the ongoing test tasks and completed test tasks. First, we can see we were able to manage a pool of bench clusters, and we also have a lot of tasks to be set for the convenience of demonstration. And I'm not going to do that. The process of submitting code to trigger CICD. We will directly demonstrate this manual. We manually triggered this test. Then this MappingSpace will go to the bench cluster far away from me, issue a test order, tell it I want to implement a test. Then this is our ESU system. This is an automated testing software. Then this automated testing software is related to one of the benches is connected. So MappingSpace will call up this this automated testing software. What about this testing software? It will also initiate this bench test. You can see it's being tested now. The whole process is automated. Okay, in the process of test, as you can see on this page, you might think of it as a software test. Actually, no. There's actually a bench attached to the back. There's a test being done on that bench. So let's take a look. Let's take a look at the condition of that bench. We can see the test software just now, and what's actually attached to the back of it is this kind of gantry. So this test software is on the hardware. Do this test. You can see that it stays with the video just now. Similar. You can see that during the test, there will also be some changes in the voltage value here. That actually means it's a work in progress. You can see there's some variation in the numbers here. Also, after the test we just mentioned, this result will be automatically uploaded back to MappingSpace and establish traceability with requirements. Let's take a look. Some of these tests have been done. Then after the test, we can see its test report here. We download one of the test reports, and then we can open up this test report to see one of my test results. Okay, so what did the process engineer do? I am in this video. I'm not going to demonstrate the test report relation to requirements after parsing. If you are interested, you can follow my follow-up video. So what does the engineer do during this process? He just changes the code. He submits the code. All subsequent processes are automated, and they can be tested at random. Select a test bench in the training pool, then send it back. Then let's compare this with such a test bench system and without such a test bench system. It's a change in efficiency. Before there was no gimbal rack. Then our benches need special personnel to manage them. Counted. If something goes wrong, we need someone to deal with it. Then let's say our customers or suppliers. We need to use this remote bench for testing. Then sometimes we need to send him the gantry. The first is to occupy our bench. Second, it will also cause some costs for our logistics. During the testing process, sometimes some invalid versions will be generated earlier. That's due to the swiping of this invalid version. Will it cause damage to various vehicles and benches? Every time will cause some losses. After having the gimbal rack, we can write before the official brush. Do adequate testing. To avoid this situation, there is no CICD. Without this automated test bench cluster, all our tests, probably all manual tests, or there is a standalone under the counter cluster. But we often have to wait then this efficiency can also be greatly improved. So we can see, in the ledger management of the platform, the impact is very tangible. The staff was immediately reduced. Then in terms of automated testing, the effect is also very obvious, can be obvious. The decrease in our staff increase our efficiency. Interested friends, come and click the URL in the lower left corner to try it.